Let's see. All right. It seems that we are live once again, Nidhi. Amazing. Beautiful Thursday. Good morning, good evening, good afternoon, good night, whatever you are. It's time to learn. That's what's important. My name is Victor Munoz. I'm a developer advocate at Metis L2. And we wanted to have this workshop on best security practices for smart contracts. Now, today we have Nidhi, another team member of the DevRel department. Nidhi, how are you doing today?
All good, Victor. All good, going good. I'm super excited
Amazing.
for this workshop as well.
Look, tell me. So, what I can see right now on the screen, I guess, is kind of the topics that we're going to be covering today, right?
Yes, this is what we are going to cover. Let me. This is the exact side that what we going to cover. Yeah, we're gonna look at the basic of the smart contract security and building secure smart contracts.
Amazing. Okay, so these are the basics to stay safe if you're a Web3 developer or Web2 developer learning about Solidity and smart contracts and all of that. This is something that is going to be very helpful for you. Just so you know, like we are live on multiple channels right now. We are on YouTube, on X, and yeah, and on X as well, like in the developer account that we have and in the main Medis L2 account. If you guys can reshare this with the rest of the community, we would really appreciate it. If you can subscribe to our YouTube channel, all that kind of stuff, it really, really helps us to spread the good word about, all of these educational initiatives that we have at Medis L2. And if you have any questions, I'm not entirely sure if you're going to be able to cover all of that today because we have quite some material to study. But for sure, we will be making sure to get back to you after if we are not able to cover everything in this session. So rest assured, all your questions will be answered at some point. So, Nidhi, why don't we get started with this nice presentation?
We can start, or if we want to wait for a like 1 minute, we can wait. As I can see that people are joining.
Oh, you are right. It's only 2 minutes and a half. And we have right now, I can see 70 viewers on the Medis L2 account, a few more on the Medis developers account, and just one viewer on YouTube. Hello to the person that is watching us on YouTube. We really need to improve that. It's hard to get discovered on YouTube with live stream, so that's why most people are active on X. But still, it really helps us if you guys provide comments, likes, retweets, and all of that, and ask as many questions as you may have. We will be taking care of you, and we will try our best from the Metis Developer Relations Department. And yeah, like Nidhi, what is it in the meantime, while we wait a little bit more, what is it that gave you kind of the motivation to go for this specific topic?
Uh, well, because I feel that this is one of the most important topic in the blockchain world. When we like almost, we can say that it runs on the trustless environment, but still users. Depends on the trust of the project, right? It's all on the trust. So, and when we heard about the smart contracts, it's immutable once deployed on the chain, immutable. So there are high risk. What if there is a vulnerability in the contract? What if somebody can hack the contract easily before you get that your contract code has something that needs your attention? So what if somebody gets that attention before yours, and what if the just hack happen? So we feel that securing smart contract is one of the most important and necessary thing before you deploy on the mainnet. So that is the reason that we have seen many developers deploying and developing on the Medis network. So why don't we give them the workshop about the security, how they can secure their deployment. So that was the main reason that I got inspiration that okay, let's share this thing with the our community as well, because we have been hosting multiple workshops for the multiple different topics. So we thought let's cover this as well.
Yeah, absolutely. You're right. Like every time you want to, deploy your dApp to mainnet, it's always necessary that you do some security checks, some testing
Definitely.
before anything else. And if you're going to like do something more elaborate, like a DeFi protocol, then definitely you will need an audit, right? It's not enough just to do the testing and all of that. So thanks so much for providing this context. I see some people on YouTube saying great work, team. So the DevRels are trying our best here. So okay, I think that we are now like we kind of double down those numbers. Thank you guys for the support. We're going to be here building and building and trying to provide more educational content as always. And so yeah, I think Nidhi, we are right on time now. So
Yeah,
let's get started.
we can start, of course. Absolutely. So, welcome again, everyone. Good morning, good afternoon, good evening. So, thank you all again, once again, for joining this session. As I mentioned before, that today we'll be discussing an important and incredibly important topic in the blockchain development, securing smart contracts. As you all know, that smart contracts are the heart of the decentralized system. I mean, it it driving trustless interactions and automating processes, but with the greater power, it says, like, with the greater power comes with the great responsibility, right? So ensuring the security of these contracts, it's not just the best practices, I'll say, but it's essential thing to maintain the trust and the protect the assets and safeguard the users. So in this session we're gonna cover smart contract basic. I'm pretty sure that most of the you knows about what are the smart contracts, but we're going to cover the basic of it and security challenges what we have in the blockchain world. We'll also have a look at the road to audit steps to secure the smart contract development. We'll also see the types of testing, also the common vulnerabilities that are most important when you before most important to check before you deploy anything on the mainnet. And we'll also have the key recommendations what you can have the the I mean the tools and the techniques that we're gonna share with you. So before further ado, let's get started. I hope everything is good. I mean, the screen is visible, right?
All perfect.
All
We're
good.
all set. And
All good. So, so let's start by revising the basic of what we are working with, the smart contracts. So, these are the self-executing piece of code. Um, I mean, where the terms of conditions are. I mean, the conditions are directly written in the code itself. So when they are made, they automatically execute the transaction, not the transaction, but it get automatically executed, right? So automating transactions and ensuring trust without the intermediaries, it's what the smart contract about. So now let's see, like, I mean, why security is so critical in this world, in this tech. So as we all know that the the blockchain itself, it provides the immutable and transparent nature of the smart contract. um, is the double-edged sword. I feel that once it deployed, they cannot be easily changed. It is immutable, right? This mean any bugs or vulnerability in the code can become the permanent risk. I mean, there are the solutions that if you have the any bug or any issues in your deploy smart contract, we have the some solutions like proxy contracts. You can redeploy or you can change the logic of the contract. But what if what if somebody can check that one? What if someone can have that attention before you do have? So I mean, once it deploys, they are permanent there, right? So we
so
have.
one question regarding this, Nidhi. So sorry to interrupt, but I want to make sure that people kind of understand the basics here about, you mentioned a proxy contract. Can you elaborate a little bit on that?
Sure. So when we say the proxy contracts, it means, let's say I have deployed smart contract, and if I find something fishy over in the smart contract, I want to change the logic of it. So there are the patterns. We call it proxy smart contract. We basically use it to upgrade the smart contract. So it's another day topic, but like if I'll explain in the depth, it will take my a long time, but yeah, I'll keep it short. I mean, it delegates the call to the proxy smart contract, and that's how we can change the logic of the contract, but we cannot change the data that have already in the smart contract. So so again, I mean, um, there are the option, but not the it's not the fully mutable. So we have also seen that we have seen the consequences in real world incidents like DAO hack. I mean, most of us know about the DAO hack, right? Which resulted in loss of nearly around $150 million. Also the poly network bridge. So even the DAO hack was not just, they just stole the funds, but also it led to split the blockchain into two, like Ethereum and an Ethereum Classic, right? So uh, these are the reasons that the security is so much critical and so much important when we are deploying or developing any projects on any chain. Let's get on to the let's look at the smart contract security challenges. So um, all right. So first up is immutability. So when we talk about the key challenges in the smart contract, so immutable code is one of the most important one. That once smart contract is deployed, like as I just said, that it's well stone in it is well like set in stone. So this make any bugs or vulnerability impossible to fix, like unless you redeploy the entire contract, which can be like logistically nightmare. I mean, uh, let's say like we have stored like a lot of data on the smart contract, then we're gonna lose it, right? So one of the most important security challenges that we have in the smart contract world, another one is the transparency. So um, smart contracts are on the blockchain, so everything is visible to everyone, so that's great for trust, right? But it also means that attackers can study your code like in detail, looking for weaknesses and exploit it. So it's the transparency is the challenge as well. But we as we're gonna look the tools and techniques that we can apply. So and then there is the economic value, like if the smart contract often holds like significant amounts of funds, right? Mostly in the DeFi world. So this make them an attractive target for hackers to, the more money at a stake, the higher they incentivize for a bad actors to find a way in. And the complexity, the final one, the complexity, as the functionality of the smart contract grows, um, so does the complexity of the code. I mean, let's be real, like the more complex the code is, the easier it is for mistake to creep in, right? So this is the another important thing when we are developing a smart contract. Let me move to the next slide. Okay, so let's see the road to the audit. So um, the road to auditing your smart contract is, honestly saying, I mean, a bit different than the traditional software development. I mean, think of it as this way, like developing a smart contract is more like designing hardware than writing a typical software, right? Why? Because just like hardware, once it is out there, it is incredibly hard, like, and often impossible to fix the mistakes. Errors in a smart contracts can be costly. I mean, in both in terms of financially and user trust. So we really want to get it right for the first time. I mean, we cannot take a risk with this one. So um, one of the best way to avoid issues early on is by writing your test case first. I mean, once you write the smart contract, we can write the test cases, and we can. It might sound like a bit counterintuitive, but I mean, writing test is before the code itself. It really works. I mean, it ensures the code. It ensures like your code behave correctly, exactly as expected, and it really helps to catch the vulnerabilities early early on before coming to the bigger problem. I mean, it's kind of having a safety net as you are building. So 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 build, test. If you feel that, of course, refactor. I mean, if you feel that if we need to change anything in the code, we're gonna refactor it and repeat. As simple as that. But yeah, so let's see the common vulnerabilities in a smart contract. All right. So let's take a closer look at some of the most common vulnerabilities in a smart contract. All are the this is not the all, but yeah, this is the most common ones. The re-entrancy attack. We almost all might have heard about the DAO hack that happened just because of this vulnerability in the smart contract. So these are the pitfalls that come up time and time again, and understanding them is critical to avoiding costly mistakes. So first, we have the reentrancy attack. So this is when an external. We're gonna have a look on this particular attack on the next slides, but let me give you the basic overview of what it is. So this attack is when the external contract is able to repeatedly call back into the original contract before the first execution is complete. It's a little bit tricky to understand, but one of the most famous vulnerability. It's been behind the some massive exploits in the past, as well as I just mentioned, like the DAO hack we mentioned earlier. Uh, the next is I'm sorry. The next is integer overflow and underflows. So this happens when, let's say, calculation exceed the maximum or minimum values allowed by the data type. So leading to unpredictable behavior, like I mean, even though like newer version of the Solidity handles this better, we have the libraries to handle this, but it's still something to watch for, especially in the old old code base. I mean, when you are using I mean, most of us will be using the newer Solidity versions, but if you are using the old one, then this is the most important thing that we cannot avoid. Another issue is unprotected access control. So if you do not secure who can call certain functions in the smart contract, you are leaving a door open, wide open, I'll say, for anyone to take control of your contracts critical functionalities. I mean, there can be multiple functions that cannot be called by public. It Some of them should be internal, some of them should be external, some of them should be private as well. So, and even if it's the public, not all the users or not the all the public can call it. So it should be there should be an condition that only owner can call it, on only the project owner can call it. So this is the something that we have to look for, like, I mean, for everyone to take so that not everyone can take control of your contracts uh, critical functionality. So basic, I mean, yet surprisingly the common mistake that we can have in the contract. Another issue is denial of service via gas limit. So I mean, denial of service through the gas limit. Attackers can basically exploit this by making certain uncallable or failing transaction that depends on them, effectively locking up parts of your contract. I mean, Let's say if your contract have the for loop, I mean, I'm going a little bit technical more in detail, but let's say if your code have the particular function have the for loop in the function, then there can be this hack can happen there, as if we have the like lots of amount of parameters coming in the for loop, it gonna run out of the gas, and it can stop the not stop, but it can definitely lock the parts of particular of that function, unchecked external calls. So if your contract interacts with the external ones without properly handling the responses, so you could be leaving yourself open to all kind of exploits. Like always validate and manage those interactions carefully. So these vulnerabilities are not just are not just the theoretical, but they are the real issues that have lead to real world losses. So yeah, I mean, recognizing and addressing them early is one of the best thing that we can do as a smart contract developer. Okay,
So,
so
Nidhi, I have a question before we move forward because, okay, you mentioned like different kinds of vulnerabilities and things to look at on the smart contract, but I was wondering which is like the most common attack.
the most common attack is the reentrancy attack and the front running attack. So as I said earlier as well, the reentrancy attack was the issue on the DAO, not the issue, but yeah, was the reason of the DAO attack that led to split the Ethereum into the two block, I mean, chain like Ethereum and Ethereum Classic. So I mean, we do have the solution for that. For the reentrancy one, we're gonna look at on the next slides. I mean, after few more, we're gonna have the little bit technical details of the few vulnerabilities that we're gonna look at. I mean, there is the price oracle attack as well. So we're gonna look at that. So should we go to the next slide?
Yeah, let's do it. Amazing. Thanks for clarifying. And this is a great thing to discuss as well. Like audit doesn't mean absolute security.
Yes, important reminder. I mean, an audit is not the same as absolute security, right? I mean, I cannot stress this enough. An audit is a crucial step in the process, sure. Like it helps really to identify the vulnerabilities. It gives you the confidence and it signal to users that your contract has been reviewed by the experts. But at the end of the day, it's just the one layer of the security. It's not a magic bullet, I'll say. So smart contracts are the complex. I mean, it's really complex. Like there is no room for mistakes. Like it cannot be avoidable. So and even the best audits cannot guarantee that your code is 100% free of issues, right? So attackers are constantly evolving, finding creative ways to exploit contracts in a ways that even experienced auditors may not anticipate. So you can think of audit as a safety measure, but not the finish line. So this is why ongoing um, vigilance, I mean, robust testing, and honestly, a culture of security uh, throughout the development life cycle are so critical. Security is not a one time step. I mean, it's an ongoing process. Keep that in mind as you move forward, right? So even if we have the audit of any particular of project, particular just smart contracts or the whole project, it definitely not the absolute security, but yeah, it's add one another security layer to your project, to your smart contract. Okay, we gonna look to the secure smart contract development. So let's talk about the key elements of secure smart contract development. So this is not a one step process. I mean, yeah, as said, um, it is a series of practices that work together to minimize the risk and ensure like we have the robust and mm, um, smart contracts without vulnerabilities. So first is testing. We're gonna look the tools and techniques on the last slide as well, but let me give you the overview. So this is the backbone of this secure development. I mean the testing side. You need to test every possible edge cases, simulate attacks, and stress test your code under different conditions. The earlier and more comprehensively you test, the fewer surprises you will encounter later. The next one is guest optimization. So this is again one of the most important thing when you're writing the smart contract is that many of the smart contract uses, excessive gas can lead to higher cost of the users, and it might even run into execution issues. I mean, optimizing gas usage ensures that your contract is efficient and sustainable, is especially in environments with the variable gas prices. So we also have the uh, gas optimization technique GitHub repository that you can we will share it with you guys on the X. Please check it out if you that would be really helpful for to for to write secure smart contracts with the gas optimizations. Another thing is then there's the documentation. uh, I mean, have the clear and thorough documentation. It's not just nice to have, but it's essential. I mean, whenever you are developing a smart contract, a clear documentation, it's very essential. It helps your team to understand the contract's logic and design, and it's invaluable for auditors and collaborators. I mean, well documented code is easier to debug and maintain the overtime, right?
And also for yourself, right? Like sometimes you are working on many times, like working on many things at the same time,
Yeah,
and you then lose track because things get a little bit complicated and you have been building for a while. So having documentation not only is important and good for security reasons, for collaborating with others, but also for yourself. So that's
yeah.
a great point, Nidhi.
Definitely. I mean, it's really important part of the, cycle when you are developing and not about just the smart contract, but in general as well. Then we have the peer reviews are okay. So peer reviews are another critical steps. Having a fresh set of eyes look at your code can uncover issues. If I am developing smart contract, then there is a possibility that as a human, there can be the human error as well, right? So as a person, as a human, I might have missed something, but the developers, my peers, it tend to have to get too close to their own work, right? So the peer reviews help catch blind spots and improve overall quality. I feel. And finally the audits. So as we discussed earlier, audits are must. They give you the external and expert assessments of your contract security, but remember, an audit is not just the end, it's the part of an ongoing process. So secure development is not about doing one thing perfectly, but it's about doing all of these steps well and consistently. So let's check the types of testing. So, okay, so let's say once you have developed the smart contract and you wanna have some testing. Testing is like hands down one of the most critical steps, I'll say once again, in building securing smart contracts. So let's break down the key types of testing and why each one matters. So first one, we have the unit testing. So this is um, you as the test individual functions, where we test individual functions or components of your smart contracts in isolation. It's like catching each piece of puzzle separately to make sure that each works perfectly. on its own before you fit it into a bigger picture. I mean, let's say we have the sets of functions in the smart contract, right? So we test each function separately before running the whole contract, and before checking the whole contract. The next is integration testing. This is about verifying that different parts of your contract work together as expected. It's not enough for each piece to work in isolation, but when combined, so they need function to seamlessly, especially in a complex system. So integration testing is another variant that we do after unit testing. And then there is the invariant testing. This ensures that the specific properties or the condition remain true. I mean, no matter how the contract is executed. For example, you might want to guarantee that a contract's balance never drops below zero. So no matter what the input we give it, but we wanna make sure that the contract balance is never going below the zero. So I mean, that's just the example, but yeah, this we do in the invariant testing. And then we have the penetration testing. uh, this one is the big one. I mean, this is where you simulate attacks to try and identify vulnerabilities. You're essentially thinking like a hacker. So probably your contract for um, I mean, we are looking like if our contract weaknesses in our contract, and assessing how robust our security really is in the current contract, right? And finally, we have the first testing. So this is where you feed random or unexpected inputs into your contract to see how it behaves. The main goal is to catch the edge cases or scenarios that might not be obvious during the normal testing, but could still lead to unexpected behaviors or crashes when it deployed. So unit testing and first testing and invariant testing. These three are the most common testing patterns that mostly auditor use it. And then there is the flow as well for the auditor. We can have the another session for that particular topic.
Yeah, I have a question here for you, Nidhi, because okay, if I'm a new developer and you're telling me, okay, you have to do this test, and then you're presenting me like all of these options, should people go with one? Should people do all of the testing? Like, what would be the preferred recommendation and why?
So yeah, so basically it's not like we just if whether we are a new in the, I mean, in the auditing part, I mean, in the security section. But if you are a new, or if you are already into this part, the thing is that we don't do like just one testing for this smart contract, the another I mean, we do all together. I mean, there is the flow that first we do unit testing, maybe we do manual testing, and then we, for some functions we have to check the unit testing. For some we do first testing, as I said, that we fits random and unexpected inputs to the contract to detect unexpected behaviors or crashes. So that's how we do, like, I mean, to secure the whole contract, we do like all together. All good.
Crystal clear. Sorry, my mic was mute. Crystal clear. Thanks.
Okay, so let's see the common vulnerabilities. So let's check the reintensi attack, as we did mention before, but let's have the, I'm sorry. So okay, so reentrancy occurs, as I said, when a contract calls an external contract, and that external contract calls back into the original contract before the first call is completed. Pretty like I'm tricky tricky to understand, but yeah. So this create a loop. where the attackers can repeatedly call the uh, withdraw function to withdraw the funds before the contract actually updates its balance. So now on the first slide, on the slide, you can see that the example of the vulnerable code in the withdraw function, uh, it sends the ether before updating the balance. So that's a big no because it leaves a window of opportunity for reentrancy. So we do have, I mean, an attacker can exploit this by deploying malicious contract and looping the withdrawal function and draining the funds. So it's just falling back the withdraw function. So if we move to the, okay, let me, okay, so if we move to the attack code, this is the attack code. This, just ignore the red line. I mean, it's not the vulnerability, but yeah, just the syntax thing.
So wait,
Okay.
just to make sure I'm understanding, in the previous slide, you showed like a sample of a contract that would be vulnerable to a reentrancy attack because it had a function that you can easily attack. And this would be what you're now showing is like the code that would perform that attack, correct?
Yeah, this is the code, the attack code. So you
I see.
can see, I mean, how simple it is for an attacker to, take advantage of this. So in this contract, like the attacker deploys the contract and calls the vulnerable contract in a loop and exploiting the reentrancy flow to drain the balance. I mean, we can see in the attack function here that, I'm sorry. Okay, so we can see in the attacker function that it's calling uh, the 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 vulnerable contract, and in the fallback function, like we can see that it's calling the withdraw function. So until it's draining the funds, cause in the previous slide we can see that the balance is not getting updated um, before sending the ether. So this is the common vulnerability that we can see. So what are the solution? Um, I mean, after few hacks of with the reentrancy attack, we have got some patterns. I mean, we call it check effect interaction pattern. So always update the state variable before making an external calls. I mean, here in this contract, in the withdraw function, we can basically just update this balance, the line number 20 and 21. 21 line number can be just before the code of the line number 17. So first we update the balance and then we send the ether. So that's how we check, we call it check effect pattern, interaction pattern. And of course we are now like we do have the non-reentrant modifier, so ensure that which ensures that no reentrant calls can be made to the same functions during the execution. So pretty easy to use. I mean, we have the library for this one, so you can just use the modifier as well. So, and of course we use modern solidity compilers, I mean newer versions of the solidity which offers protections to prevent reentrancy attacks. Using the latest version, like, I mean, we enable security feature is, I mean, always a good idea. Underflow overflow. So what are they? So underflow overflow, these issues arise in arithmetic operations when numbers exceed the limits of the data type. Let's break it down. I mean, this mostly uh, can happen in DeFi space. So first, let's see the overflow. So this happens when a number exceeds its maximum limit and wraps around to the minimum value. For example, as we can see here, that in an unsigned integer with a range of 0 to 255, if you add 1 to 255, the result will wrap around to 0. So this is overflow. What is underflow? So there is an underflow, right? So which is the opposite? It occurs when a value goes below the minimum limit and wraps around the maximum. So for example, subtracting 1 from 0 in the same unsigned integer will result in 255. So in the example code here, let me show you the, yeah. So in the example code here, we can see that how this vulnerability can slip in. So if the increase log time function here, if this function allows user to input, I mean, large value, it can cause an overflow, resetting the log time and potentially enabling unintended withdrawals. So this have the, on the line number 21, this is the vulnerable to overflow. So how do we mitigate this risk, right? I mean, these are the few best practices. Mostly we use to avoid underflow and overflow. We use the SafeMath library from the OpenZeppelin, and we ensure that SafeMath ensure that arithmetic operations revert on the overflow and underflow. So that's how we avoid this exploit. And solidity, I mean, the newer versions from the solidity 0.8.0 onwards, like arithmetic operations include built-in checks for overflow and underflow. So if an operations exceed the limits, it automatically reverts, making it, I mean, much safer. Okay, this is again another important vulnerabilities that we have to check it: on-chain randomness. Why it's challenging, and how to handle it effectively in the smart contract development. So let me explain the problem with the on-chain randomness. So um, in decentralized system, like achieving true randomness is not as straightforward as it might seem. I mean, if you look at the example here, randomness is being generated by using block hash or a block dot number. While this might look like a clever approach, but it's actually not secure. Why? Because these values are predictable and can be manipulated. So the randomness, I mean, we generate the random number for any calculation, for anything, I mean, to do anything on the smart contract. So we use, in this particular contract, the block, I mean, we use a block hash or a block number, but it's not the secure. So for example, I mean, miners have the control over the blockchain parameters, such as block hash and the block timestamp. If it outcome of your contract depends on these values, um, let's say for a game or a lottery, so they could manipulate them in their favor, as they can attack on the, not on the contract, but they can manipulate them in their favor in such a way, like it's getting like someone roll the dice, but also giving them control over the dice itself. So I mean, because blockchain data, like block numbers or hashes are public, attackers can simulate your contract's behavior in advance. So they can predict the outcome of your random functions and act accordingly to exploit the results. So these are the solutions that avoid on-chain randomness. I mean, simply put, do not use values like block dot number, block hash, or a block timestamp to generate randomness. Um, these are predictable and manipulated, as we just discussed. Instead, we use Chainlink VRF, verifiable random functions. Chainlink VRF is a widely used solution for generating tamper-proof randomness, and um, also random values should not be reused across multiple contract interactions. So I mean, once a random value has been consumed, request a new one for the new interaction. And this minimizes predictability and ensures that every interaction is unique and secure. Okay, let's check the price oracle. So, yeah, this is again critical component in many smart contracts because mostly smart contracts uses price oracles, especially those in the DeFi. I mean, as important as they are, they can also be source of serious vulnerabilities if not implemented securely. So, what is price oracle? So, is it is the mechanism that provides the external data to your on-chain data. I mean, like the price of a set in USD to your smart contract. Since the blockchain contracts cannot directly fetch the data from the outside world, so that is the reason that they rely on the oracles to bring the information on chain. So this is very essential for the contracts uh, in the decentralized exchanges, in the DeFi world, in the token swaps, in the lending platforms. So what is the problem here? So the problem is like if an oracle is compromised or manipulated, the data on your contract relies on become unreliable. I mean, this creates vulnerability that can be exploited by attackers, which can cause financial losses. As say, I mean, what? Okay, let me. So, what is the vulnerability in this code? If you look at the example code here, so the contract actually depends on the external entity to call the update price. So, in the update price, we can see that. It depends on the external entity, and while the function has to check to ensure that the only oracle can update the price. So there is no guarantee that the oracle itself is secure, but but I mean, or I mean, it's secure or the data it provides is accurate, right? So how how attackers might exploit it, right? So let's see how attackers can exploit this. So attackers can manipulate prices if the oracle is centralized or poorly implemented. Then attacker could feed a fake price to the contract. For example, they could make the price of any token or any asset that we are fetching it lower than the really it is, and allowing them to buy tokens at unfairly cheap rate, right? So that is the one issue. And then there is the another source of truth of the price, that any compromise that to that oracle. I mean, the single point of failure, I mean, I'm talking about whether accidental or malicious compromises which can affect the entire contract. It and the front running attack that I earlier mentioned, an attacker could observe an oracle's price update transactions and front run it to exploit it to the new prices before it's actually reflected in the contract. So this is how they can attack on the your contract. And I'm sorry. Now let's see how do we can solve this. So uh, definitely we can use the decentralized oracles. I mean, this is the best practice, I'll say, to use decentralized oracle networks like a chain link and API 3. These guys do have the decentralized oracle networks to price feed your on-chain data. We always perform sanity checks on the price returned by the oracle. For example, I mean, we ensure that the price is within the reasonable range, and I mean, not zero or negative. So, and also we compare it to the recent prices or predefined thresholds to detect vulnerabilities, avoid single point of failure. As I'm saying, that never rely on a single oracle or a data source. And implement fallback mechanism, and add logic to handle situations where the oracle fails or provide invalid data. For example, revert transaction if the price feed is invalid. Use a backup oracle or hard coded default values as a last resort to maintain the functionality while addressing the issue. Okay, so key recommendations. I hope we are not running out of the time. Okay, we do have the 10 minutes and we do have the few more slides. I'll keep it quick. So, protect withdrawal functions. So, this one is critical, as we said that um, reentrancy attack and access control attacks, this can lead to the attackers to withdraw the funds from your contract. So mostly try to use access modifiers, always validate balance before processing transfers, uh, check if patterns, avoid using self-destruct. um, Self-destruct function is to erase your bytecode. It not erase your bytecode from the blockchain, but it is the convenient way to remove a contract, so which again introduce a range of risk. So it can break applications flow by suddenly destroying a contract, like leaving dependent system or a users in a broken state. So like let's say if any project has a self-destruct contract in the smart contract function in the smart contract, and any owner have the access of this function particular function, then what if they just call the function on the tomorrow morning, and the fun and the entire the all the functions of the smart contract will not be working, right? So it means they can easily stop their contract, and it poses the risk of other dependent contracts as well, right? um the third one is keep modifiers simple and stateless. Modifiers should only validate conditions. For example, checking if the caller is the owner or ensuring certain criteria are met. Avoid including logic that updates the state variable in the modifier. So it can lead to unexpected behavior if we update state variables within the modifier. And okay, let's move to the next slide. The fourth one is use safe math for the solidity versions below, which is like most of us will be using the newer versions, of course. But if by any reason if you are using the older versions of the solidity, make sure that we use safe math library for it. Implement ring guards. Use open zaplin's ring guard to prevent this attack. Use message.sender and message.value very carefully, as these two variables are a bit fundamental to how contract interacts with the blockchain, but they can also be source of vulnerability if not used correctly. So message.sender always validate the caller, so avoid making assumptions about who the sender is until you unless you explicitly check if using it modifies like only order or custom validation logic. Why this recommendations matters, right? It is more like the solution that we discussed earlier for the different vulnerability attacks. But why this is matters, so this actually this practices address some of the most common yet critical vulnerabilities in the smart contracts. So by following these recommendations, this all we can make sure that we are taking a concrete steps towards writing more secure and robust smart contracts. Okay, so tools and tools and techniques. So okay, so whenever we have, like, let's say the smart contract, and we want to audit it, so what we do and how we do and what kind of tools we use. So first, we can start by, thoroughly reviewing the smart contract score to understand its logic and the functionality. I mean, which function uh, perform which functionality, and I mean, basically we review the code base. And then there is the automated testing tools like Slither, Mythics, to detect the common vulnerabilities. And it's pretty much easy to use this kind of tools. I mean, Slither is pretty easy. You just install it and you run few commands, and it will give you the gas report as well. I mean, which function use how much gas and all. So, I'm sorry. So use static tools. I mean, we call it static analysis tools. So recommend to use this after reviewing the code base. And we do have the manual testing. Conduct manual code tests to identify logical errors. Um, and the edge cases that automated tools might miss, right? And then we have the code styling and the best practices. I mean, this is one of the most important thing that, matters a lot. I mean, to ensure that the code flow follows all the best practices, and others to proper styling for readability for and maintainability. Because there will be the high possibility that if we write a code, then the other person, or I mean other developer or any other smart contract auditor might be looking at your code. So this is the very important that we have the code styling and the best practices. Then we have the formal verification. I mean, this is for the mathematically verify that the contracts behaves as intended, and aligns with its specification. And do the penetration testing as mentioned before, and have the comprehensive audit report detailing all the findings, and um, create a audit report which have all the findings and categorized the severity. I mean, uh, critical, major, or a minor, that recommendations for the remediation. So, and we can share this list to educate others on how effective auditing techniques for the smart contract. And we can even attach this audit report to our project to ensure that users have the trust on our um, project. Oh, okay. So, and that's the wrap for the workshop of today. I hope that you have learned the ins and outs of the building secure smart contracts, covering vulnerabilities, tools and techniques, and best practices. Right? Feel free to drop any feedback or comments for any improvements, or on if you would like to go in detail of particular topic on the smart contract security side. Please reach out to us on Telegram or on the X, so we can have the next session on that particular topic.
Yes. So thank you. First of all, thank you so much, Nidhi, for the entire presentation. It was super clear. I think that at some point after this presentation, we're going to be providing a link to a GitHub repo on Metis Edu. You can check it out on GitHub so that you have all of the material and the snippets of code. And one question, because I don't think we have time for many questions from the audience, but I do want to take my privileged position to ask you something very basic, by the way, so no worries, about AI. So when I have my smart contract, I'm building my first dApps, and I'm not sure about how to do all of this testing and whatnot. Can I use AI for this? What is your take on this?
um you can get, like, if you don't know anything on the smart contract security side about the auditing and all, you can take a help of AI to get a flow, like I mean how you can start and what can be the flow that, as I um, mentioned on the last few slides. But we cannot rely particularly on the AI, that okay, we just give the code to AI, and if it's checking that okay, this is the vulnerabilities in this contract and this and that. But yeah, we definitely cannot totally be reliable on the AI. But yeah, we can get the flow, like how to start, what to do, like how do I do, what I do first. So let's say it says the review the code base. So okay, so definitely as a human we have to review the code base. Yeah, I'll say that not totally, but we can have the little bit help from AI.
Got it. Makes sense. I think that as AI evolves, maybe we are going to be
Yeah.
relying more and more on that. I'm not entirely sure. So I'm waiting to see how this plays out. So thank you so much again for this presentation. Like I mentioned before, we're going to be having a public repository so that you can check out all of this material and let us know in the comment, like, what do you think about this workshop? If you have any specific questions, or if you would like that we cover a different topic next time, we are open to that, right? We are trying our best to push Web3 education for developers at Metis L2. And of course, your input is much valuable. So thank you so much again, Nidhi. And for the people in our audience, please make sure to subscribe to the YouTube. Really helps. Please make sure to retweet this kind of streaming. It also helps a lot. And I'll see you on the next one. Okay. Thank you. Bye bye.
Bye bye. Bye bye.